Okay, so can you tell me what is a pure substance? What is a pure substance?
A pure substance is um is a substance which only has one type of molecule or like atom, which are
Yes, only one type of atom. Yes, exactly. So, pure substance have, you can say, a specific melting point and boiling point. Let's
Mhm.
suppose if I give you the two glass of water like this. In the first glass, that is A, there is water, and in the second glass, that is B, in
Mhm.
which I have water molecule. Okay, I have water basically. So we have to identify in which glass we have a pure water and in which glass we have impure water. So what we are supposed to do, we are supposed to boil these two glasses of water. So when, like, you can say that when water is going to boil at exact 100 degrees Celsius, and you know that the boiling point for water is 100 degrees Celsius. So if the water boils at 100, if the water boils at 100, so I can say that the water is pure. I can say that the water is pure. So basically, you can identify the substance, you can identify the purity of a substance by just boiling or melting it. By just boiling or melting it. So if the substance is being boiled or melted at a specific temperature, so we can say that this substance is a pure substance. So the
Okay.
same goes with this. We have to identify that which glass has pure water. So you will say that boil both A and B. If one of them boils at 100 degrees Celsius, this is pure water. This is pure water. But if the liquid is impure, I'm not talking about specifically the water, whether the liquid we have, obviously each liquid would be having their own fixed melting and boiling points. So let's suppose if the liquid is not boiled at a specific temperature, I can say that that liquid is impure. That liquid is impure. Are you getting my point?
Yeah.
Good. And then for solids, we check the liquids through the boiling points. Obviously, the liquid boils. But whenever we talk about the solids, obviously the solid is being melted. So then we would be looking at the melting point of solid species. If the solid is being melted at a specific temperature, so we can say that the substance is pure. The substance is pure. So for
Mhm.
the solids, we have to melt it. For solids, we have to melt it. Obviously, the melting point is supposed to be fixed. If the melting point is fixed, let's suppose iron melts at 1550 degrees Celsius. So if you are going to melt the iron, and you would see the melting point that is exact 1550 degrees Celsius, so you can predict that the iron is pure. But if the iron is not going to melt at this temperature, so you can tell that the iron is impure. So
Yeah.
so we have different methods to identify the purity of a substance. One of them is boiling point, and then melting point, and then chromatography. Like we have few methods by which we can identify the purity of a substance: by boiling, by melting, and by using chromatography. Let's suppose we would be doing this, but I told you regarding the melting and boiling point, so they are supposed to be fixed. If they are fixed, so you can say that the substance is pure, and if they are not fixed, so you can say that the substance is impure.
Mhm.
Exactly. So then in this chapter we are going to discuss how the things are going to be separated from each other. Let's suppose you have two solids, you have two liquids, you have one solid and one liquid, you have two gases. So we would be learning in this chapter how can we separate the samples. So first of all we are going to do filtration. In filtration, what we do generally, we generally separate solid from the solvent. We separate solid from the solvent. Before going into the detail, can you tell me what is meant by the term solute and then
Um,
solvent?
okay.
Sorry?
So the solute is the thing you're the thing you're putting like the liquid, I think. Is it the liquid you're putting in and then the solvent is the solid?
Solute may be the solid, solute may be the liquid. But remember, solute is a substance which is dissolved in a solvent. Solute is a
Okay.
substance which is dissolved in a solvent. Let's suppose I have to add sugar. I have to dissolve sugar in water. I have to dissolve sugar in water. Okay. So ultimately, the sugar is the solute which is dissolved, and the water is a solvent. And the water is a solvent. So basically, what is solute? So I'm supposed to write that which is dissolved in a solvent. And the
Okay.
solvent and the
This-
solvent
mhm.
in which the substance is dissolved. Generally, this is observed that solute is in a less quantity and solvent is in a more quantity. Like if you are going to do a comparison between the amounts of solute and the amount of solvent, so you would see that the amount of solute would be lower and the amount of solvent would be the larger, would be the greater. So, and then what is saturated solution?
Saturated solution. Um, a saturated solution is it where there's only
Basically,
one
saturated
carbon,
solution
two,
means that
two
we
carbon.
cannot we cannot dissolve we cannot dissolve more solute in it because this is already saturated. Like
Okay.
it's a full of solute. Let's suppose you are going to dissolve sugar in water. Ultimately, you can dissolve specific amount of sugar in water, but you have to specify the amount of water. But you have to specify the amount of water because we generally, this is standard that we always look at the 100 gram of a solvent. Obviously, amount should be fixed so that we can do a comparison between the solubility of different substances. So always we take 100 grams of the solvent, that is water in this case, and then you would be starting to dissolve sodium chloride in, you can say, in a solvent, and the amount of solvent is 100 grams. So we have observed that only 10 grams of sugar is dissolved in 100 grams of a solvent, only 10 grams of sugar. And
Hmm.
then I have realized that, you can say that, um, I'm supposed to add more amount of sugar in that solvent. But the thing is that the maximum capacity was the 10 grams of sugar that is dissolved in 100 grams of solvent. That was the maximum capacity. So if you are going to add more amount of sugar in that solution, you cannot add it more. You cannot add it more. So at that time the solution is called the saturated solution. Like the solution in which further solute cannot be dissolved, cannot be added. That solution is called saturated solution. Are you getting my point?
So a saturated solution it's basically a solvent which cannot dissolve more.
Which cannot dissolve more amount of solute.
Yeah.
So when its maximum capacity has been reached, so afterwards it cannot dissolve the substance anymore. Okay?
Okay.
Yes. Good. So we would be doing filtration. Filtration is a separation technique in which we can separate the insoluble particle, which can separate insoluble particles, that is the solid. We can separate insoluble particles, that is the solid, from the solution.
Okay.
Okay, from the solution. That's called filtration. Let's suppose if someone has mixed, you can say, sand into the water, ultimately then we are supposed to separate the sand from the water. So we are supposed to do a filtration. Okay, we are supposed to do a filtration. So first of all, the filtrate is a solution that is passed from the filter paper as a result of filtration.
Okay.
Like filtration, in the filtration, basically, um, we have two important terms. Number one is the filtrate, and number two is the residue.
Hmm.
Okay, filtrate is a solution that is passed through the filter paper, but residue is a substance which is left behind on the filter paper. Just like this, if you can see this, basically, this is a residue which is left behind on the filter paper, and this is your this is your you can say filtrate. This is your
Mm-hmm.
filtrate which has passed through the filter paper, which has passed through the filter paper. Okay.
Okay.
Yes.
Okay.
And then I'm going to pour mixture of sand and water. Ultimately, the water would be passing through the filter paper, leaving behind the sand,
Sound.
leaving behind the sand particle, obviously, because they are having the larger size. And whenever we use a filter paper, ultimately there are some pores in the filter paper, but the pore size is very small. But the thing is that the pore size is very small, so they would not allow the sand particles to pass through the filter paper. Ultimately, in this manner, you can separate the sand particles from the solution.
Water
This is
particles.
what the filtration. This is what the filtration. Okay.
Yeah.
Yes. And then, uh, like, what if I have salt and water? What if I have salt and water? Can you do a filtration if you have salt in water?
No, because it will almost all of it will dissolve. It depends how much salt you're putting in.
Exactly, but the thing is the salt is soluble in water, so it would be difficult to separate the salt that is soluble in water. We always do filtration whenever we have insoluble salt.
Yeah.
Hmm. And then this is the mechanism of a filter paper, how the filter paper works. Basically, I have shown some small pores on the filter paper just like this. These are the
Mm-hmm.
very small pores. These are the very small pores. So when the sand particle is coming to pass through this filter paper, when the sand particle is coming through the filter paper, obviously. So here are some pores in a filter paper. We have some pores in a filter paper. So ultimately, this is the size of the sand particle, and this is the size of the water particle. So obviously, the size of the water particle is very smaller, so it can pass through the filter paper. It
Mm-hmm.
can pass through the filter paper. And
Yeah.
then these are the sand particles. Obviously, the size of the sand particle is larger as compared to the water particle. Ultimately, the filter paper won't allow to pass through this sand particle. So that's why you can say that in this manner you can separate the salt and The
Water.
water. Exactly. Now you can see this.
Okay.
Okay. Yes. Yes.
Okay.
Then examiner would be giving you the diagram and you would be labeling it. Okay, so you must know how to label the diagram. Where is the residue, where is the filtrate, what is the funnel, where is the filter paper, and what is the retort stand. This is called the retort stand. This is called the retort stand. This is the beaker. This is a funnel. This is a clip. So you should know each and everything regarding the apparatus of the filter paper. Okay, like the filtration. Sorry.
Okay.
Hmm. Then we have evaporation. Then we have evaporation. As a result of evaporation, we would be getting the pure salt or impure salt.
Okay.
Yes. So evaporation means that when you are going to separate those particles which are soluble in water. One of the best example is sodium chloride and water. Ultimately, sodium chloride is soluble in water. Ultimately, the sodium chloride is soluble in water. And when you have dissolved sodium chloride in water, ultimately there would be a lot of positive ions and a lot of negative ions.
Yeah.
No, sorry. Basically, let's suppose we are going to separate soluble particles from the solution. So let's suppose we have a salt. Okay, so when you are going to heat the water molecule, like the mixture in which the salt is dissolved, so when you would be heating the mixture in a china dish, this is a dish in which we have a mixture, that is the salt and water. So obviously when you would be providing some heat to this mixture, so ultimately the water would be evaporating. Ultimately the water would be evaporating and leaving behind the salt. But there is a problem. The problem is that because you have provided strong heating, to evaporate the water molecule, so that all of the water molecule would be evaporated and leaving behind the salt. So as we know that we have provided some sort of heat, some strong heat. So remember, after providing heat, the salt that you are going to separate from this solution, the salt that you are going to separate from this solution is would be in the form of powder, like we
Okay.
would not be having some crystals, we would not be gaining some crystals of the salt. Why? Because the crystals are broken down at higher temperature. Ultimately you have provided some higher temperature, so the crystals would break down into the powdered form. Ultimately, the salt that we have separated as a result of this, you can say, evaporation, so the salt would be impure. So when, like, if someone says that, sir, if the salt is impure, so obviously there would be some impurities, I would say yes. So then he is supposed to say, why don't you separate the impurity, rather than just, again, frequently you are saying that the salt is impure, the salt is impure. So why the impurities? Problem to separate them from this solution. There is a problem. The problem is that, uh, and also the size of the salt is also a very small.
Okay.
Ultimately they would be intermingled with each other, they would be evenly mixed with each other. So I cannot separate the impurity from that powder. Why? Due to the difference, due to the very smaller size. Let's suppose in some cases we would be having larger sizes. So obviously we can separate the impurity very easily if the size of the impurity is larger. If the size of the impurity is larger, but unfortunately in this we are going to separate the purity, separate the impurity. So, but the problem is whenever we do evaporation, so the salt would be in the form of powder. Ultimately the size of the particle in a powder is very small, so you can say that um,
Yeah.
it's impossible to separate the impurity from the solution since the size of the impurity is very smaller. So to avoid this problem, to avoid this rush, so we generally what we are supposed to do, then we would not be doing evaporation, then we would be doing crystallization. Then we would be doing crystallization. In both technique, interestingly, in both techniques, same happens. Like liquid to gas, liquid to gas, liquid to gas, liquid to gas. So ultimately, in both processes, you would be converting your liquid into the gaseous form, But in evaporation, you would be getting impure salt, okay,
Mm-hmm.
and in crystallization, you would be getting the pure salt. So these
Yeah.
are the some theoretical checkpoints you are supposed to note it down on your notebook, okay?
Okay.
Yes. So now you can summarize it. What is the difference between evaporation and crystallization? Yes.
Okay, so the difference is when it's converted from both are from a conversion from liquid to gas, except evaporation leaves impure salt, for example, and the crystallization will leave pure salt and large crystals with it.
Okay, good.